to run through quickly on this basic exponential applications. It says evaluate all work, showing all work and checking. How do you do this? What does this little symbol, sigma, capital sigma, represent? What does it tell you to do? Anthony, what does that thing mean? The sum. It means the sum. The sum. Okay. Mackenzie, what are you plugging in?
So you plug in n, which is either you go between 0 and 8.
Beautiful. So we are plugging in 0 all the way to 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. To this expression. Oh, that's a 6. To the n. So, we've got a lot of numbers to do here, yeah? Well, anything to the 0 is 1, so 3/2 to the 0 is 1, times 256 is 256. Gina, plug in 1, tell me what you get. Allie, plug in 2, tell me your answer. Morgan, 3. Joe, 4. Alyssa, 5. Brittany, 6. Nadia, 7. Hunter, 8. Tell me the number you get. Leave it as a fraction if you get a fraction. Cool? So what do we get when we plug in 1? 384? 2? What is it? Thank you. 3? 4? 1296? 5? 6? 7? 8. Okay, so Anthony said that sigma means add those numbers up. So we have to take those numbers and add them up in the calculator. Is that a fun time? Not particularly, but we're going to do it anyway. So what's the shortcut way to do this if you have only one letter in the summation? What's the fast way to do it? We've shown work. Anybody remember where you go on here? Go in here. Do you see it? Yeah? Type it in exactly as you see it. Does this work if there's 2 letters? No. Make sure, and I want to make sure I say this really quickly, this will always give you the outside set of parentheses. You're going to put the 3/2 parentheses there. Make sure your n exponent goes on the 3/2, not on the outside. If you put it all the way on the outside, then it's going to raise 256 times 3/2 to the n power, which is going to give you an atrociously large number. So if you do it this way, we get a sum of 19,171. So here I'm going to write sum. 19,171 is my final answer. I've shown work and I have an answer. Easy? Okay. Now, that can be a pain in the neck, which is why you're given that formula on your formula sheet that we've been using. The one that looks like this. S sub n equals A1 minus A1 times R to the n over 1 minus R. That one that's on the formula sheet. Yes, it says geometric series. What you have to remember about R is that it's representing growth or increasing or decreasing. So whatever the rate is, you do 1 plus whatever percent or 1 minus whatever percent that you're using. We've talked about that. Yes, we talked about that yesterday. If it's a percent. So, we haven't done one like this in a while, so I'm only going to run through these two. These two are easy. You've been doing this kind, but I want to talk about these two because they're a little bit different. In order to use the summation here, the sum of the finite geometric series, which is exactly what we did before, at the top we used a summation symbol. We have to know that this is the first, second, third. I don't know what term 512 is. So I have to figure that out. So we have A1 is what? And what's R in this situation? 2. 8 over 4 is 2. So we're trying to figure out when we stop. Where's this 512, right? When do we get there? So there's several ways to do this. First, what I would do is write S equals A1 minus A1 times R over 1 minus R. And we're looking for what we're plugging in for N. So you can go here. We know 16 is the third term times 2, 32 times 2 times 2. We're getting there. Okay. So 16 was the third term. So 32 is the fourth term. 64 is the fifth. 128 is 6. 7. 512 is the eighth term. So we're going up till n equals 8. So this is the eighth term. So I'm putting an 8 in my exponent as my subscript. Go to the calculator, type it in. Mitchell, when you get an answer, can you tell me what it is? Agree? Okay. So same thing in number 2. First term is 5. Second term is 15. Third term is 45. So we know A1 is 5. What's R? 3. What term is this one? Figure that out. So it's the sixth term. So we're finding the sum of the first 6 terms of a geometric sequence. A1 is 5 minus A1 times R to the 6th power over 1 minus R. Type it in. Emily, tell me what you get as an answer. $1,820. So that's the only sneaky thing. I haven't given you a sneaky one like that. I've been giving you this kind on homeworks, where you're just kind of plugging into the formula. So that's the sneaky kind. Now, you actually have a really good basis of exponential growth and decay. And so I was really impressed before Christmas when we talked about sequences and series. You guys remembered the whole growth decay thing from Algebra 1. It seemed obvious to you, or you kind of remember it from maybe some science classes. I don't know. So when we talk about exponential growth, we're talking about population growth, cell growth, viruses spreading, nuclear reactions, or economic growth. When we talk about decay, we're talking about like chemical reactions, what happens when you take a prescription drug, radiation effects, motor vehicle values, and retirement funds. Once you retire, you start using the money. You don't have money going in. You're spending all of the money. So looking at these equations, both of these are set up exactly the same. Look at the formulas. A of t equals a sub 0 parentheses 1. What's the only difference between growth and decay? Plus and minus. Does it make sense that growth is plus and decay is minus? Nobody's surprised, yeah? And then to the t, because t is typically time. So the thing you need to know about R is that you're given this as a percent, and you need to convert to a decimal. What does percent mean? Out of 100. So you know to divide by 100, true? We did this before Christmas. So what you also need to know is the A sub 0 stands for the initial value, and A of t stands for final. The A of t notation is not A times t. That's just function notation, like f of x. All right, so we're going to start with some basic ones. Nothing fancy is going to happen today. You're going to think this is easy. It's a formula we plug in. But you are required to put these formulas in your brain. Okay? So, in the last 12 years, an initial population of 38 alpacas on a farm grew by 7%. So, we have exponential growth. Yes? A of t equals A0, parentheses 1 plus r to the t. Write an exponential model given the number of alpacas, n, after t years. Okay, so what are we using instead of A of t? What letter? N. So we're going to say n of t equals. What's our initial population of alpacas? 38. Then in parentheses, 1 plus, how do we rewrite 7%? So 7% is 0.07. So when we add it to 1, we have 1.07 raised to the t. This is an exponential model, so it has variables on both sides, yes? Now it asks, how many alpacas are on the farm after 8 years? What do you do with the 8? Plug it in for t. So n of 8 is equal to 38, 1.07 to the 8. And since we're talking about alpacas, Josh is going to tell us how many whole alpacas we have, not partial alpacas, right? 65. Okay. Yay! Is anybody excited about anything we've done? No, this seems very straightforward. You did this in Algebra 1. Now, Part C asks if there are 38 alpacas in 2016, that was our starting, during what year will there be 53 alpacas on the farm? What are we solving for? T. So where are we putting 53? N of 8, right, so on the left. So 53 alpacas equals our 38 alpacas times a growth of 1.07 to the t. Now, this is solving. You just did this on your quiz. But this looks scarier because there's decimals, Miss Newman. It's not that scary. So, step 1. Get the weird thing alone. What's the weird thing? 1.07 to the t. What does that mean we need to do first? Divide by 38. That's not going to be a pretty number, so don't put it in the calculator. 53 over 38 is going to be it's going to look uglier as a decimal than it does as a fraction. So leave it. Okay. Now, t is in the exponent. Can I get a common base? Nah. So what do I have to do? Change the form to log form. So log, what's the base? 1.07. What goes in the parentheses is equal to t. So, calculator, quickly. Log 1.07. Okay, 4.917. But it asks us what year. So this is 4.917 equals t, but it's asking us for year. So 4.917 years after what year? So just add 2016. Do it in the calculator because sometimes when you don't do it in the calculator, you do things that are weird. 2020. If you're 0.9 of the way through the year, are you still in 2020? So we say during 2020. Is that cool? All right. I'm going to skip to a number 8. Listen to me, you skipped all those other ones. Yeah, it's the same thing. That's all. Cool? All right. The that's MSRP. That's a typo. Manufacturer suggested retail price of a Chevy Volt Premier is currently $37,570 and depreciates. What does that mean? Decreases by 18% each year. Write a model, V of t, that represents the value of the Chevy Volt in t years. Is this exponential growth or exponential decay? So, what's the only difference between growth and decay? It's going to be minus in between. So, A of t equals, we always have the initial out front, 1 minus whatever the rate is. How do we write 18% as a decimal? Just 18% is 0.18. So when we plug it in, you're all 4 steps ahead of Miss Newman. You're like, Miss Newman, it's just in the parentheses, it's 0.82. Get yourself together. Okay, sorry. What am I putting in front of those parentheses, though? Yeah, the initial value, and I got to squeeze it in here because I didn't leave myself enough room. Okay, so there's our model. And all V of t represents is like f of x, meaning it's the value based on time. Because f of x stands for the value of a function based on its x value. So now it says, according to the model, how long, what are we solving for? T. Will it take for the car to be worth half of the value? What do I need to figure out first? Yeah, let's find that out. 37,000. Oh, I got a bunch of junk in there. Was it 37,750 divided by 2? 37. Oh, did I? That one? 18,785. So 18,785 is equal to our model. Okay. So we're solving for time. Get the weird thing alone. Divide by 37,570. But I don't like big numbers. You hush. You're fine. It's a number 2, you know. What should that be? Think about what we just did. Yeah. Okay, so that equals 1/2 equals 0.82 to the t. Can we get a common base? No, I'm busy that day, right? So it must be log. So log, what's our base? 0.82. What goes in the parentheses? Okay, find t. Somebody tell me what it is. Is anything I really told you new? Now, it's kind of like geometric sequences back from December. You learned this back in Algebra 1, but we always need a solid review of all of the things, right? And then the solving is exactly what we did yesterday. So, now I have to tell you about a special case. There's always something, right? There was always something that's a little extra. Now, this is going to sound familiar to you. It should, at the very least. Have you heard the words half-life? What is the definition of half-life?
Like, divide by 2 or multiply.
Divide.
Divide by 2 every year.
It's the amount of years that it takes for it to be half.
Reduced by half. Okay. So it's the amount of time it takes something to decrease to half of its original. Yes? So like, what's carbon? Like 2000 or 2070 or something like that takes for it to decay to half its original amount. So if you're decaying by half, you're doing 1 minus 0.5. What's 1 minus 0.5? 0.5. And how do we represent 0.5? Because Miss Newman is a fraction freak, yeah? Okay. So, let's talk about the pieces. A still stands for the final amount. P, they like to use P. P means principal amount. It just means the initial amount still, okay? So you might see principal amount or initial amount, okay? The 1/2 is because it's half-life. I'm going to call, so this one is half-life, but that can change. If it says decays by, or no, let's do it this way. What if it says doubles? What goes in those parentheses? What if it says triples? 3. Yes? What would be quarter life? 1/4. Yes? I don't think they'd ever write that, but hey, who am I? T still stands for time, but H. H is the half-life time. So what is the half-life? So if the half-life is 9 weeks, you put time divided by 9. If the half-life is 5,720 years, H is 5,720. Yes? Okay, let's do some of these examples. A radioactive element decays with a half-life of 20 hours. What percent of the original amount exists after 12 hours? Did they give me an initial amount or a final amount? What word do I have a bubble near? Percent. When you're calculating percent, what number is easiest to work with? 100. So, use 100. We're going to have our initial amount be 100. It says half-life, so we put 1/2 in parentheses. We're finding a final amount. After what time? 12 hours, but over a half-life of 20. So, calculator. 100, 12 over 20. 65.975. No, it said what percent. Nailed it. Because I used 100, I'm good. All right. Let's do an easy one. The half-life of Pepto-Bismol is 3 hours, so H is 3. Sophia takes 525 milligrams. What's that? P, initial amount. How much will be left in her system after 5 hours? What's that? T. So because it said half-life, I know it's decreasing by half. I could write 1 minus 0.5, right? But like also no. So A equals initial, 525. Half-life means we have a base of 1/2. 5 hours is our time divided by the half-life of 3 hours. Calculator.
165.365.
Okay? You'll never look at medication the same again. It's like when you take Advil for a headache, and they say every 4 hours, right? Because then it starts to wear off. It's because of the half-life. Whoa, right, whoa. Okay. This is my favorite question of all times, because it messes with you. Wahaha. 30% of a radioactive substance decays in 35 years. 30% of it is decaying. That's a decrease of 30%, right? Decrease 30% in 35 years. That's our H. What percent to the nearest tenth of a percent remains after 50 years? What's 50? T. So what were we not provided with? P. Yes? P or A, actually. We don't have a final or an initial amount. But they throw in the word percent. So we get to just pick a number. If they just, I could pick 5, and then in the end I could calculate the percent. I could pick 2 or 1. What number is really easy to work with when you're talking percent, though? So we're going to start with 100%. 100%. And in the parentheses, you can do this 2 ways. It's still decay. It's 1 minus 30%. So 1 minus 0.3 is really what? 0.7. To the T, 50, over H, 35, is equal to our amount. This way, when we get our answer, it is already in percent mode. I don't have to go back and calculate out of the initial amount. So, A equals 100.7 to the 50 out of 35 to the nearest tenth of a percent. One minus 0.3. What do you get?
16.0.
So what's the nearest tenth? 60.1%. Okay, so everybody spy on your homework. I want you to spy 1 and 2. That geometric series that you wrote it down. Oh, that's not the right homework, Miss Newman. Sorry. You wrote it down on your pink formula sheet. What am I trying to say? Stamp sheet. There we go. That's what I'm trying to say.